And this data generation can be scalable, so they can generate 100 records, 1 million records, 10 million records. It actually doesn't matter. Once you have the model, you can generate large amounts of data set from them. And it's not a function of how large the source data was. You can have a smaller source data set and then generate a larger data set, synthetic data set from that afterwards. So the advantage here, of course, is that you don't give access to real data to the data consumers. You give them access to simulators or models of the data. And we found that data custodians and data controllers are more comfortable sharing models than they are sharing raw data sets. So this is one effective way to enable broad access to data set to data consumers within an organization or even external to the organization, just by providing access to different types of data simulators. So the two big questions that come up with synthetic data are, what are the privacy risks for synthetic data? And then second question is, how good is it? So I'll touch upon those briefly before closing off. So there are some privacy models for evaluating the risk of re-identification for synthetic data sets. And here's an example of an evaluation of privacy risks, essentially identity disclosure risks for synthetic data on two health data sets. One is the Washington Hospital Discharge Database, and the other one is the Canadian COVID-19 case database. And they vary in size. One is 650,000 individuals, and the other one is around 90,000. Here we look at the risk of re-identification for fully synthetic data set as well as the original data, and we use a threshold of 0.09. So 0.09 is a commonly used threshold, at least for the sharing of health data, used by the European Medicines Agency and Health Canada and Centers for Medicare and Medicaid as thresholds for what's deemed to be acceptable non-identifiable data sets.